Architecture and Enhancement. Um, the purpose is to know more about the enhancement and have a look, or you can say overview about the MySQL 8.0 architecture, and we'll discuss in depth about the enhancement part. So our agenda is, next slide please. So today's agenda is, we will go through the architecture part on in-memory structure and on disk structure of MySQL 8.0, and later we'll cover the enhancement part. In enhancement, there are a lot of major changes in 8.0, but we'll talk about a few of them important. That is data dictionary, what change from InnoDB side, what change in configuration and login, and security and replication. So these are the enhancements we'll discuss. Next slide, please. Okay. So whenever we talk about this MySQL architecture, in generally, we divide those in two sections. One is in-memory structure, and second is on-disk structure. So the purpose is, uh, it's very inefficient to access data frequently from disk if you have a data on disk for each request, and that's the reason there is a concept of memory where we extract the data from our disk, we keep that in our memory, and we use recently access or recently access data from our databases without again going to disk and fetching the data from the disk. That is the purpose. So we'll start from in-memory structure, that uh, how it works in 8.0. The highlighted part is undo table space and the temporary table space. That is what is something changed majorly, I can say. And also there is a data dictionary part. So that this highlighted part, we'll talk more about it in further enhancement. But let's have an overlook of in-memory and on-disk structure. Next, please. Okay. So when we talk about the memory, the main area we allocate is buffer pool. That is for our InnoDB storage engine, and what it has, it store our indexes and data. It cache our indexes and data. So we can easily access our frequently asked data from memory rather than going again and again to a disk, which is very efficient, and that's how our optimization, or you can say that's how we can gain the performance for our database. So that is the main purpose. So how it works, so it works on LRU algorithm, which is recently used. I mean, if you have a pages recently use recently used pages, those pages will be moved towards head, and if your pages not use for a while, those pages will move to tail, and our current pages insertion will happen in the middle, and depending on the how frequently we are accessing those page will move towards head or tail. Again, if we are not at all accessing particular data, eventually that data will be evacuated from memory. It will purge from memory, and next time whenever you will access that particular data, again it will be cached into our memory. So this is how our buffer pool usually works. It can be configured on the fly. So till 5.6 it was not possible to resize this while server is running, we can say dynamically, and we were required downtime if you want to change this variable. But from 5.7 this thing is changed, and you can resize your InnoDB buffer pool on the fly also, and that is one of the a big thing where you can avoid the unnecessary downtimes. The purpose of having this InnoDB buffer pool is uh, uh, to save overall, to gain the performance, And how we can start, it can be set up to 80% of your total RAM memory, but uh, I would suggest to start from 50% because there is a possibility that other OS resources may need a memory. So that's, it's not a good idea to start directly from 80%. So depend on your workload, start from 50%, and gradually, if you see there is enough free space, you can increase this on the fly. And I mean, since we have a dynamic, we can change this dynamically. This is a good practice to start from the lower, and then increase it as per your need. That's the suggestion for this. Next slide, please. So buffer pool, how we can monitor this buffer pool? So there are two options. You can execute. You can view the details of buffer pool using show engine InnoDB status, where you'll have buffer pool and memory area section, where you can see the how many number of pages I have in my memory, what is the total buffer pool size occupied currently, and these other details. Apart from that, there is a table in information schema called as InnoDB buffer pool stats. That table as well you can check if you want to check, if you want to get the details about the buffer pool. About the configuration of this buffer pool, if you want to for performance reason, if you want to change, if you want to change few things, uh, there are a lot of things, but these are the major things you can do. First thing is InnoDB buffer pool size. You can resize it as per your need. For if example, if you are seeing a lot of conjunction of pages, if you are thinking after checking the show engine InnoDB status, you are thinking that I need more memory, or I have enough amount of memory on my server available that I can utilize. Uh, in that case, you should increase your buffer pool size. That's the first thing. The benefit is, let's say if you have a 20 gigabytes of data, and if you have 32 gigabytes of RAM memory, in that case your database can act as an in-memory database because you have a sufficient memory as compared to your data. Second is, the buffer pool area is a common area where all operations will happen. There will be concurrent transaction, concurrent request will become, and there will be, after some time there will be conjunction. So to avoid that traffic or no concurrent thing, you can divide your buffer pool in instances. Okay, and you can the only condition is the buffer pool size should be more than 1 GB. This is the condition. And you can, if you have more than 1 GB, 1 gigabyte buffer pool size, you can set your buffer pool instance, so it will divide your buffer in pieces, in number of instance, and that's how it will handle the concurrent request very efficiently. That is the second thing, how we can improve the, how we can uh, improve our performance using changing the buffer pool size. Is InnoDB buffer pool flushing. So InnoDB flush pages when percentage of, I mean, there is a setting when it reach your dirty page count reach to particular percentage. There is a variable called as InnoDB max dirty pages percent, and if it reach to the threshold, it will start flushing. So it's set to 37% of initially it's set to 37%. And again you can do the configuration if you think, if you don't want to hold uh, uh, if you I mean, how frequent you want to flush your data, that you can decide using that configuration variable. Next, please. Okay, change buffer. So this is, so we have a buffer pool. As you can see in the diagram, we have a buffer pool, and inside the buffer pool there are few sections, because buffer pool only cannot work alone. There are few supporting supporting, you can say, supporting or configuration, or some supporting sections it has. And using those supporting things, we can it's coordinate with the supporting factors, and it will know it will work together as a unit. So change buffer is a part of your buffer pool, and what it does is uh, when we store data for a cluster indexes or a primary indexes, our indexes and data are stored on same leaf. So it is very easy if you're changing your cluster index data while writing it, it can immediately do the changes in index as well. But for a secondary indexes it is difficult, because secondary indexes has a reference to particular data, and they may write randomly on a different page, and it is very difficult or inefficient, you can say, to write randomly on disk. And to avoid that, to avoid that, this change buffer pool will help us. It keeps, so whenever there is a changes in secondary indexes, this change buffer pool will keep those changes for secondary indexes. And whenever particular data access next time and fetch in memory next time, it will merge those changes, it will merge those secondary indexes changes to that data. And that's how you can see it's applying those changes periodically, it's merging those changes in a batch periodically, and that's how again we are avoiding the random writes on disk. So that's the benefit of having the change buffer pool. Its configuration variable is inodb change buffering, and inodb change buffer max size. You can set your size for change buffer, and to monitor this, there is a section again in show engine inodb status. You can check the insert buffer and adaptive hash index section to check your change buffer activity, how many number of secondary indexes or unmerged indexes you have. These kind of details you can uh, get from that inodb engine status. Next, please. Adaptive hash index, again, this part of my memory in buffer pool. So earlier, as I said, if you have 20 gigabytes of data initially, and eventually it will increase, but initially, let's take a scenario where you have a 20 gigabytes of a data, and you have a 32 gigabytes of RAM, which is more than your data. And so in that case, your database can act like in-memory database. Okay, so that means you can buffer all your data in your memory, and the performance, you can see the difference in performance gain in that case. But so to configure this, saying that, there is a concept of indexes. So you're moving your data from disk to memory, but on disk we MySQL keep indexes as a b tree index format. And when you're moving to memory, in that case the b tree will not work. That's the reason, to apply the indexes on data in memory, we MySQL create hash indexes automatically on that data in memory. So this thing is done by this adaptive hash index part, uh, which is handled by, again, MySQL. And you can enable it or disable it. By default it is enabled. You can disable it if you want. And in what scenario we are disabling adaptive hash indexes? When you see a lot of read write latch in your semaphore area in InnoDB show engine InnoDB status. If you're seeing a lot of semaphore wait, lot of transaction waiting for read write latch, in that case, there is it caused because of your workload, type of workload on your database. It not able to handle concurrent transaction efficiently, and it's creating a multiple hash indexes. So it's kind of a burden on your MySQL. In that case, you can disable it. Or the second option we have is, there is a concept of partition in this adaptive hash index also. You can divide your adaptive hash index area in partition. You can do that using InnoDB adaptive hash index parts. So you can divide that, and that's how you can handle multiple concurrent connections and multiple concurrent operations in different areas. So these are the two possibilities we can deal with adaptive hash index. Next, please. Okay, so this is the last part in memory we are going to discuss log buffer. And so whenever I am doing any transaction, it's very inefficient if I'm inserting something, if I'm updating something, but it is very inefficient, yeah, to write everything uh, in real time on disk. So we need to keep some data in memory for some time. For example, I started one transaction. I done two or three transactions, and I mean, it's a long transaction. And in each, for example, if I'm inserting one row, I started transaction, I'm inserting one row, I'm inserting second row. That's how I have 500 rows to insert. I cannot insert one row at a time, same time to this, because my transaction is not yet completed, and writing it to disk immediately is very inefficient. And that's the reason we have a memory thing. So this buffer pool, log buffer pool, is nothing but the area uh, to memory area for redo logs. So our redo log in MySQL is nothing but our crash recovery log. So whenever anything happen, any uncertainty, or any due to some reason my MySQL crash, uh, when this redo log will make sure that database will start in consistent state. It will make sure that partially written transaction will undo or rollback, and committed transaction will get written to exactly to my table space or my table. So this kind of work is done by redo log. But before writing to redo log, we need some buffer area. Even we don't want to write continuously in redo log immediately. So that's the reason we have this log buffer area, which will keep the data for redo log temporarily. And how this flushing mechanism work. So we have a variable in MySQL called inodb flush transaction at commit. Okay, we can set value as 1, 2, and 0. 1 is the default value from 5.7. Earlier it was 2. And what happen if you set 1 is the safest one if you don't want to lose your transaction, and we'll see why. If you're using value as 1 in a DB flush transaction, if you're using value 1, in that case it will make sure that whatever transaction you're committing, it will write from memory to your reader log or your disk. So it will make sure that your committed transaction will get written. Okay, so that's the guarantee you have uh, with this setting. If you're setting it to 2, in that case it will work on two conditions. First, OS flush, whatever flushing frequency we have for fsync operating system, and the second is in every 1 second. So these are on these two conditions, my flush will trigger from memory to my reader log. If I set it to 2, if I am setting this value to 0, in that case it will only uh, it will only write in log buffer, which is very dangerous. So let's say even if your MySQL is shut down and your OS is up, in that case also you're losing your data. Okay, so that was not the case in earlier 1 and 2. So here the 1 is safest one. Next please. Okay, let's move to the this how it works on a file system level. What architecture we have on a file system level. So in file system level we have few components which help MySQL to run and which keep the user data. So there are different files, and we'll discuss about that. So first thing is table space. Table space is like what we have in other databases is same like that, which keep our user data, our system metadata, and other information, which will help to run our MySQL. So first, table space is system table space. Earlier, this is change in this thing change in 8.0. Earlier in system table space, we used to have um, our data dictionary and undo log. These are the two components additionally we have in 5.7 by default. But in 8.0 by default, my system table space will only keep this double write buffer and change buffer. So this double write buffer is nothing but uh, 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 the area on disk, making sure that in case any crash happen or something happen, if my MySQL unable to find good copy of page, okay, uh, good copy of page, it will this double write buffer will provide the good copy of page for that particular table. So it's like having the consistent data and good quality of data. It will help to do that. Change buffer, this is the same component what we have in memory, what we discuss in memory, but this is also available on disk. In case again, in case if I'm unable to merge due to some emergency, I'm unable to merge those changes, it will get returned in my change buffer. Again, it will when in next restart, it will load in memory, and that's in the next time I'll merge those changes to my table data. So this is just for a safety thing. So this is what we have in. So overall, you can say system table space is help MySQL to run properly. Moving to general table space, this general table space is used for storing the user data. What so let's why we have a general table space. Let me give you the scenario. So by default in MySQL, we have InnoDB file per table is equal to 1, which store which creates individual table space for each table. So for example, if you have 70,000 table, so in directory it will create a 70,000 table spaces for each table. It so is okay, but what if you have your 6 application having data tables from 50 to 90,000 in this range? In that case, you can imagine in the table count goes in lakhs. So in that case, it is very inefficient, you can say, to keep that number of file. And there is a limitation also for few file system. There is a limitation also the number of files we can have in particular directory. So that is a problem. To solve that problem, there is a concept of, that's the reason we have the concept of general table space, where my problem was I have a, let's say I have a 6 database, 6 application with 70,000 tables. So what I can do, I can create a general table space for each application, okay, and I can store in that single table space. In that single table space, I can store those 70,000 tables. So you can see that now I'm storing those 70,000 file, rather than storing the 70,000 file, I'm just keeping the one file. So that's the benefit of having the general table space, to centralize everything and manage, to avoid this extra files or number of files in case if it exceed from 70 to 80,000. So to create that, we have this create table space name. You will add this data file name. You can add path also. The good thing is you can store this table space out of your data directory as well. If you want to store on separate mount one, you can do that. And while creating a table, all you need to do is you just need to mention the table space, in which table space you want to store that table, and that's how it works. Next. Okay, so if you start your MySQL by default, if you install 8.0, and when you will start your 8.0, this is what you'll see by default. So the new thing here is my binary log, bin log. So so far in 5.7, till 5.7, bin log was not enabled by default, but in 8.0 it is enabled, because it's pretty important for a production system to have this bin log. In case in for a various reason, if you don't want bin log, you need to disable it manually, or you need to disable, you need to add the configuration in your my.cnf. So let's say if you forgot to, I mean, you're not aware, and no, I mean, in case even if you have this thing by default enabled, there is one more change in 8.0. There is a variable to purge binary log after a particular duration. Earlier we used to, I mean, it was like unlimited. Until unless you specify, it will not delete. But now the variable name is expire log days. The expire log days default value set to 30 days. That means even if you forgot to set this thing, your binary log will get purged in 30 days. Before, whatever you have older than 30 days, those binary log will get deleted, automatically purged by that setting. Buffer pool, IB data, and IB log file, these are the component we discuss. These are the default, no change in this. The new thing you'll see is this inodb temp1, and you can see hash inodb underscore temp directory. So this is something change. In 5.7 we had by default we had this ib temp table space for a temporary tables, for a temporary tables, you can say. But in 8.0, it is they introduce not only for a global, but for on a session level also you can have a table space. So whatever you're doing in session, that can store differently, and whatever operations happening on global level, that can store in my global temporary table space. We'll discuss later in detail about this. This is something new, MySQL.ibd, table space for data dictionary tables. This is something completely new. What majorly changed in 8.0. This is my data dictionary table space, where I'm storing my metadata information about my tables and other database objects. Earlier, this information use was, I mean, in 5.7, this information is stored in my IB data one, that is my system table space. So now that thing is changed, and now I have this mysql.ibd file, separate file for my data dictionary to keep my metadata information. In the end, you can see a default undo table space. Again, this is something change in 8.0. Earlier, by default, if you are specifically not specifying that you want undo table space separately, this undo table space is part of my system table space with my data dictionary. And the problem here is, because of having undo table space and system table space, there was a problem, and we'll discuss that problem in next slide. Next slide, please. Okay, so as I said, what's the problem when we have undo table space in our system table space? So let's say I have undo table space contains undo transaction. So whatever transaction not yet committed, it will change the history, you can say. If you, in case if you want to roll back, this is the place where it will pick. This is the place from where it will pick the data, and it will know, give the old copy of your data if you want. So let's assume that you're running very long transaction, and it's not at committed, and it's because of that my system table space is growing. The size is increasing, and there is nothing I can do, because there is no option to truncate it. There is no option to remove that space from system table space. That was a problem. So to solve that problem, we have the undo table space separately, and we can truncate this as per our, I mean, as we can truncate this automatically as well as manual. So this is the benefit of having undo table space separately, rather than keeping it in system table space. So condition is, if you wanted to truncate automatically, in that case you need to enable this variable inodb undo log truncate, and it will, for that there is a requirement. You need at least two undo table space, system table space. If you want to do it manually, in that case you should have at least three undo table spaces to work automated and manually together. That is the condition we have. You can drop your undo table space at runtime. Okay, how it will work? When you'll drop a particular table space, it will wait to make sure that whatever data is there, it will get flush or truncated, and after that only it will drop your table space. So it's very safe when you drop your undo table space. So if you want to add extra undo table space, if it required, this is the syntax: create undo table space. You will mention your table space name and add data file. You will give the this is the naming convention. You can give the name, and that is the extension. So by default, it will create a two undo table space, that is 001 and 002. I mean, as shown in picture. But if you want additionally, you can create, and that is that those will be your user defined undo table spaces. You can get the information about undo table spaces in your information schema database inside InnoDB and InnoDB table space table. If you want to know more about undo table space. Next, please. Okay. Now, as we discussed earlier, undo and temporary table space, something is changed drastically in 8.0. So let's move to the temporary table space. So earlier it was only one temporary table space. So what is the use of temporary table space? Table space to store data for temporary operations. If you are creating anything on the fly and to perform certain operation, you need some temporary tables internally. In that case, it will use the temporary table space. So in 5.7, we only have this IB tab 1 file, which is 12 MB by default. Size is 12 MB. It's by default enabled. So whenever you start your MySQL, it will create a new temporary file, and whenever you are stop your MySQL, whenever you perform shutdown, that time it will make sure that in a shutdown process it will remove your temporary table space, and in each restart it will create the new temporary table space. So that's how it works. The new thing in 8.0 is session temporary table space. So rather than using the same thing for global operations and session operations, in 8.0 we have a session temporary table space which is dedicatedly created for particular if you are running a session and if you are doing any temporary operations, that temporary data will get stored in your session table space. And the moment you the moment you log out from your session, immediately it will free the space. Immediately it will truncate or no delete everything what those operations. That's how you are saving the space rather than keeping it for forever and waiting for a shutdown. So if you are doing something in session, if you are doing something in session, you are done with your session, you completed everything, there is no point of keeping that data in a temporary table space. So that's the reason we have a session temporary table space introduced in 8.0. Next slide, please. Okay, let's talk about enhancement now. Apart from the architectural changes, there are some new features and enhancement in existing feature, which is very important for DBA and MySQL users to perform day-to-day operations. And so we'll talk about the data dictionary, that how the data dictionary is something new. It was not there in 5.7. It was there as a part of a system table space, but now we have a separate dedicated table space for a data dictionary, which is completely a new thing. InnoDB encryption, we'll talk about that. That is the major thing change in InnoDB. Configuration, error, and login. So what are the changes happen in configuration and error login? What are the changes happen in replication and security? Next, please. Okay. So if you look at the diagram for 5.7, you can see that whenever you create a table, it create a FRM file, and depending on the storage engine, it will create for other files, like for MyAsm it will create along with the FRM, it will create MyD and MyI file, which will keep MyD will keep data, and MyI will keep your indexes. For InnoDB, it will create a .frm file and .ibd file. So .frm will keep your metadata, and .ibd file will keep your data and indexes. For trigger also, it create a file called to keep the trigger structure, and no, there are a lot of other objects which we create to keep the metadata of those objects. It's creating a separate file. So the problem here is, you can see in data dictionary I have mix of everything. I have files on file system level, I have MyAsm tables, and I have InnoDB tables. So when so for monitoring purpose, definitely I'll access my I need the information about the metadata. I wanted to know what are the how many objects we have, and what are the details for those objects. And that's just imagine that you have 80 to 90,000 tables, and you want to know few things about those table, and for the same reason your MySQL will access the table structure or metadata information. In that case, it will read those files, all 90,000 files from disk, which is really slow, and that was a problem. If you have a large number of table, you'll see the slowness and all if you are querying on information schema. So in 5.7, nothing is centralized. We have a different components to keep our metadata in data dictionary, and that's the reason we don't have any option to optimize our queries, optimize our information schema. So that was the limitation we have in 5.7. To remove that limitation, in 8.0, native data dictionary based on InnoDB is introduced. It's a transactional data dictionary. That means it supports the transactional as well. And it support it's created using the InnoDB storage engine. That means all table we have inside the data dictionary will get created in InnoDB. So you'll not see in your data directory or a database directory, you'll not see this frm.par.opt these kind of files in 8.0, because all your metadata information we are storing in our data dictionary. So that's how we centralize everything in 8.0, and this is the source of truth, you can say, one single point. And even if you are querying, you can buffer it, you can rather than reading the files, you can keep a particular thing in cache, and you can use those things repeatedly and in very fast manner. So that's the difference between 5.7 and 8.0, and that's the benefit of having the data dictionary separately apart from the system table space. Next, please. Okay. Next thing is encryption. So this thing will tell us how encryption work basically, and we'll see what enhancement happen in terms of encryption. So encryption introduced in 5.7, but that was only introduced for file per table space. It was not available for system table space, undo table space, temporary table space, or my general table space. So only few of the things are encrypted in my data directory, and other are not. Like bin log also not encrypted. So that is something incomplete. And just to give you the idea how encryption works. So to have the encryption, there is a plugin called keyring. We need to install that plugin, and it will enable this encryption feature. Once that plugin is enabled, uh, you can create a table. And how this encryption and decryption happen is, you have a master key which is common across server, and in each table space header you have a table space key which is act like a private key. So whenever you want to access particular data, the master key will check, go to the header. It will make sure that it matches with the private key, matches with the private key, and after doing the successful handshake, it will allow you to access your data. Even if you for a security purpose, you can rotate this master key regularly, and even if you rotate, there is no overburden, because your table space key is in header. So if you are rotating your key, you don't need to re-encrypt, or no, you don't need to encrypt your data again. The only thing it will do is, when you rotate your master key, it will update the table space header with the new master key info. So in the, for all table spaces. So that's how it will work. It will not re-encrypt your data again, because just because master key change. So that's how encryption work, and we'll see how what are the things change in 8.0. Next slide, please. Okay, so file per table space, as I said, it's introduced in 5.7, but what about the other table spaces? So other table spaces are not encrypted earlier, but in 8.0 this has happened. And for system table space, that is IB data, I can once you start, after enabling the plugin, this is the command: alter table space MySQL encryption is equal to y, means yes, no, and if you want to disable the encryption, again execute the same command, passing the n argument, that is no. Okay, so these are this yes or no arguments you can pass, and you can disable it and enable it encryption for system table space. For a general table space, same thing, but for general table space, we have a option that we can create by your create that table space. For a system table space, when you start your MySQL, by default MySQL create a system table space. So that's the reason there is no option of creating that table space. But for general table space, this is purely for storing the user data, and we have an option to create it and alter it. So while creating, you can pass the encryption is equal to yes, and that's how it will encrypt your table space. And if you have an existing general table space which is not encrypted, in that case you can use alter option, and you can alter using the alter command. You can enable the encryption for your general table space. Next, please. Okay, that is something. So earlier, for a system table space and general table space and file per table space, we have create an alter commands to do that. But for undo table space, redo log and binary log, we don't have a command. But instead of that, we have a variable, new variable, which is introduced in 8.0. So again, there is the basic condition is you should have that keyring plugin enabled, and all you need to do is, on the fly, you can enable the encryption using this variable. All you need to do is enable this. If you want to enable the undo table encryption for undo table space, just set inodb undo log encrypt is equal to on. For redo log also same thing, inodb redo log encryption is conf is equal to on. For binary log also, bin log encryption is equal to on. The same thing, the way you enable it dynamically on the fly while server is running, you can disable this thing whenever you want. So the only common point here is, if you are taking that data from disk to memory, it will be in unencrypted format, because it's in memory. But whenever it is on disk, it is in encrypted format. So that is the common thing we have in between this table space encryptions. Next, please. Okay, changes related to configuration and login. So persisted system variable is introduced in 8.0. So what is the use of this variable is to write whatever changes you are doing on the fly dynamically, to write those changes in your configuration file. So those changes will be persistent. So I'll tell you the use case and use case to describe this thing. Let's say I'm a DBA, and I change some setting today, okay, for some reason, and let's say this bin log encryption is equal to on. Let's take example. So today I decided to have enable my bin log encryption. I enabled it, and I enabled it, and my encryption is working fine. And after 6 months, After 6 months, someone comes and because of some maintenance reason, we need to restart our MySQL. In that case, I restarted my MySQL, but my setting will be lost because the only command I executed is set binlog encryption is equal to on. Okay. In that case, definitely I enabled it on the fly, but I forgot to add that in my configuration file. That's the reason in next restart my changes are lost. So to avoid this situation, definitely we cannot remember what we did in last 6 months if you are doing at work, and there is a chance of forgetting such things. So to avoid that, while setting dynamically only, you can use this persist option. Set persist binlog encryption is equal to on. So what it will do is it will set your binlog encryption on the server that time, as well as it will add those setting in this MySQL D or auto.cnf file, which is in JSON, written in JSON format. So it will add that variable, that configuration setting in this file. So in next restart, your changes will be there, your configuration settings will be there, and next restart there will be no problem. So that is the use of having this persistent system variable, introducing this variable. Next, please. You can find this file in your data directory. This MySQL auto.cnf. Login. Okay. This thing is changed. So earlier in 5.7, when you stop, you'll see the warning, notes, and error, everything. So that thing is changed. So what are the things we wanted to print in your error log is controlled by log error verbosity variable, and in 5.7 that was 3. That means it will log note, warnings, and error for your server. But in 8.0 that thing is changed. It will only log your warnings and error, no more notes. And next change is, let's say for some reason you wanted to do some debug, you wanted to more information or for troubleshooting. In that case, I would suggest enable this variable log error verbosity is equal to 3, and that's how you'll get your notes as well, additional information. So that's one thing. And another thing is in 8.0 we have an option to suppress particular warnings, error message or node. So all you need to do is depend on your log error verbosity. For example, if I'm setting 2, in that case it will only suppress error and warnings. And I can the new variable is introduces log error suppression list. In this variable, I will pass my error code, which you can get from your error log, and you can suppress that particular error if you don't want to see that particular warning, even though you know that okay, you're aware about it, but it's coming repetitively and is unnecessary filling your error log. In that case, you can suppress suppress that particular warning or error using this variable. This is the change in 8.0 for logging. Next, please. Okay, for replication there are a lot of changes, but this is I pick because I think this is also useful. I mean there are many, but this is the major thing I found. For specifically for multi-source replication, this is how multi-source replication work, where I can have a multiple master, and using different channel I can store that data in common server, common replica or slave. Okay, using the different channel. So I can have db1 and db2, db3 on separate masters, and I can store all of the data on one single server, and I can use that server as a reporting server. That is a general use case. But earlier we don't have any option to filter what we want to replicate. For example, I would like to replicate db1 for master m1, and for db, again my m2 also have the same thing, db1. For m2 I don't want to replicate the db1 database. So let's say the scenario is in m1 and m2 I have db1 database, and I don't want to for M1 I want to replicate, for M2 I don't want to replicate. So in 5.7 the problem was you can set a filter globally, you cannot set a filter for particular channel, and that thing is changed now. So I can, even if I have a same database on two different masters, and for one master I would like to replicate that database, for another master I don't want to replicate that database, so I can use channel specific setting. Uh, I can ignore it. I can say only replicate this database. So basically these are the replication filters. This replication filter now I can apply on the channel basis rather than the global basis. So this is the change. Next please. Okay. This is major thing I think in 8.0 in terms of security and privileges management. So 8.0 introduced roles. So in earlier in 5.7, if you want to assign particular privileges to user, in that case you need to write, you need to pick individual privileges like grant, select, insert, update, delete. So in that's like that way you need to pick one privileges every time, and you need to assign those privileges to user. There is no common concept, or there is no centralized thing that where I can create a particular role for a DBA, for a dev, or a set of privileges for DBA or dev or for application. There was no option in 5.7, but in 8.0 by introducing the role, um, we can have a collection of privileges as a role, and we can assign that role to your user. So as you can see, first I'll create my role. Create role, your role name is similar to your user. It's works like similar like your users. So I'll create a role, and after that I'll grant few privileges to that role, and once I have that thing, I don't need to every time when for example for a DBA or for a developer user, I would like to assign few few privileges. In that case, I don't need to mention those individual privileges every time. I can directly assign particular roles. Let's say this is the DBA access. I can assign the role to user, DBA role to user, and that user will have all privileges. I can assign the dev access role to particular user, and that user will have create, drop, select, insert, update, delete privileges. So list goes on. That's how you can organize your users. It's the best way to organize your user, and yeah, keeping the privileges and granting the privileges in good way. Next please. We almost finish. So these are the few other changes. Whenever you're creating a user, you would like to have a default role. Let's say whenever you're creating a user, you would like to have a select privileges for that user. In that case, you can create a particular role, and you can using this variable, mandatory role variable, you can assign particular role as a default role whenever you're creating a user. So automatically when you are creating a user, automatically that role will get assigned to particular user. That thing is changed in 8.0. Password policies. Regarding to password policies, password rotation policy enforcement, we there is a change in default password lifetime. Okay, we must set our password policy. We must enforce our password policy to rotate the password. That thing is changed. Old password required for set password. If you are setting a new password, so earlier if you are login and you would like to change your password, all you need to mention is your new password, even if you don't know your current password. But that thing is changed now. Whenever you'll reset your password, it is must to specify your current password and the new password in order to reset your password. Next please. Okay. It's the same thing. Next please. Yeah. So a little bit about Percona. So it's not a fork, it's a patch with following enhancement: enterprise feature like thread pool, PAM authentication, audit logs, uh, all enterprise, which are enterprise features, better performance, scalability, these kind of additional things we have in Percona server. If you see how and where how Percona works and other folks works, so this is the diagram explain from where what is coming. Next, please. So this is the other reference document. I'm going to add more, and I'll share this slide with you guys. You can refer this reference document if you wanted to know more about particular feature in 8.0. And next, that's all. Thank you, guys.
Thank you so much for that. All right, at this time, we are now going to take some questions. Go ahead and enter your questions down in the questions panel down below. A recording of this webinar will be made available to everyone within 48 hours or less. And also a copy of the slides will be sent your way as well. So our first question is, it appears that the secondary index changes are stored in memory for an extended period of time while the system waits for efficient times to write the database. If the server were to crash before the secondary index changes are written to the disk, are we looking at a corrupted data on the disk where the secondary indexes don't match to the primary?
No, it just a backup thing in case of crash. If I'm unable to find, if I lose, definitely I'll lose everything what I have in memory. So that's the reason we have this change buffer on disk in part of a system table space, which will take care of this thing. So even if you in next restart, whatever data I had in memory in change buffer, that data will get reloaded in my change buffer, and later I can merge those changes.
Thank you. Let's see, our next question is, on what frequency relog buffer flush the changes to the disk when commit variable is set to 0?
When InnoDB flush transaction commit is set to 0 every 1 second. Every 1 second, it will flush your changes from memory to disk.
Thank you. Our next question is, regarding the undo table space, do we have any specific retention to follow?
No, it's up to you. Okay, there is no default setting. The moment it gets full, it will make sure that for a new there is enough space for new data, and that's how it will get truncated. So if you see it taking a lot of space, is going, and no, in that case you can truncate. So it's depend on your workload. There is no standard thing that there is no default that it will truncate in particular days or particular time.
Thank you. Let's see, our next question is, what kind of encryption levels are provided in MySQL 8?
Encryption levels, so it's ASE, AES, so advanced encryption standard. That is what we have for encryption, keying encryption. That is the only type of encryption we are using.
Thank you. Let's see. I'm going to squeeze in one more question, and then we're going to wrap up. How are persistent variables reset? Does ptconfig diff work on these persistent versus myCNF variable settings?
Mm-hmm. So you can, since it's storing in JSON format, I need to check. It's a good question. I need to check. I got your point that what if I want to compare my my.cnf and my MySQL auto.cnf using the PT tool, but that part I need to take. I'll reply that part later in blog.
Great. Well, thank you so much for attending today, and huge thanks. Thank you so much for presenting today. We are at the top of the hour, so we hope to see you on future webinars, and we're going to conclude for the day. Thank you.
Yeah. Thank you, everyone. Bye.